evidence that our universe might exist inside a black hole? What's up with that? Well, let's back up for a moment, okay? And put some base information on the table. A black hole is a region of space and time where the strength of gravity is so high that light has no path to get out of the object. All paths through space-time curve back in on itself. Normally we think of a hole as a hole in the floor, and you fall through, come out the other side. Except it's a three-dimensional hole. You can fall in any direction. That edge, beyond which there's no return, we call the event horizon. It's a horizon. The universe has a horizon too. It is a distance beyond which no information can reach us because the universe isn't old enough for light from anything beyond that horizon to have gotten here yet. By the way, the more mass is in a black hole, the bigger the black hole becomes. In fact, if you run the math on it, it's linear. So a black hole that's twice as massive as another one will be twice the diameter. 10 times as massive, the event horizon, which is our practical definition of the size of the black hole, will be 10 times as long. There's a cool exercise we do in graduate school. You can say, given the mass of the universe, how big would the black hole be that contained this much mass? It's the size of our universe to our horizon. And it's like, wait a minute, could we be one giant black hole? The average density of matter contained within the size of our cosmic horizon matches right on with what you'd get for a black hole this size. That's intriguing. Maybe it's just a coincidence. What would it mean anyway for us to be inside a black hole? How would that work? Well, it turns out if you run the mathematics of Einstein's general theory of relativity into a black hole, it turns out a whole new space-time opens up on the other side. And you look behind you and the entire future history of the universe unfolds relative to your time frame. And so the universe you came from basically ends and a whole new universe opens up in front of you. Are we that universe that opened up in front of us? Okay, these are mind-bending questions. Well, there's recent research published that suggests that the contents of our universe has sort of a net rotation to it. Well, that'd be kind of weird. So in this study, it observed several hundred galaxies from the best observing directions you can come up with, which is above and below the plane of our Milky Way. And it noticed a net rotation of spiral galaxies in one direction versus the other. So if you look at spiral galaxies, if half of them sort of rotate like that and the other half rotate the opposite way, then they kind of cancel. But if most of them are rotating in the same sense, in the same direction, then that could hint that there's a net angular momentum of the entire universe. So what did they find? That 2/3 of the spiral galaxies measured rotated in the opposite direction as the Milky Way. So 2/3 is not 100%, but it's certainly more than half. We expect this to just be random. Normally in our lives, we think of something that rotates because some other force set it into motion to do so. And we look in the universe and everything is rotating, and then you ask, what force is making that happen? Turns out, all of our evidence suggests that when you make a galaxy or a star system or a star or a planet, there's some gas cloud that started it. If the gas cloud has any motion at all, the tiniest amount, as it collapses, its rotation will speed up. The gas cloud that was large, moving just a little, will move much faster as it gets smaller. And you know this already when you see ice skaters. When an ice skater spins and they want to spin faster, they start with their arms outstretched. And they have a certain rotation speed by virtue of that. As they bring their arms in, this is a phenomenon of physics called the conservation of angular momentum. If you start out large, slowly rotating, and now you're half the size, you're going to be rotating twice as fast. If you want 1/10 the size, you're going to be rotating 10 times as fast. Is that right? mv squared over r, right? This is why everything in the universe has some kind of rotation, because it's essentially impossible for any large gas cloud to not have motions within it to begin with. Often they're thermal motions. There's turbulence within the cloud before it sort of collapses to become something solid. Because of the turbulence within the clouds, there's no reason to think they would align with each other. They're each independent entities, so that when they collapse and the final product is spinning, there's no reason to think that the spin of this object is going to match up with the spin of an object over here. We have every reason to presume that there's no net spin direction of the universe or objects within it. So if we find and confirm that there is, we got to go back and ask, how could you get that, given our expectations of randomness? Well, that was linked to the idea that we might be in a black hole. Here's why. There's only two kinds of information you can obtain that are preserved inside that black hole. The mass, the total mass, and the angular momentum. Because anything falling in, if it falls in with a swirl, toilet bowl style, that angular momentum continues into the black hole itself. If there's a net angular momentum of the universe, where did it come from? It's not obvious that would come from a Big Bang, which is an explosion in all directions statistically evenly. What could it be? Could we be a black hole with a net angular momentum of stuff that spiraled into us? So that's where the black hole connects back to whether the universe is rotating. So I look forward to seeing whether this result is confirmed or falsified. It's an intriguing result, and the number of galaxies was not very large, just a few hundred, and there are billions of galaxies out there. So I'll reserve judgment until I see what others publish on this subject. Anyhow, that was a what's up with that on whether or not we are living in a black hole. And if we were, what difference does it make? But it's fun to talk about. Until next time, keep looking up.
If you love a good mystery, and who doesn't, check out the new season of The Secret of Skinwalker Ranch, only on the History Channel. It's America's most mysterious location, known for strange lights, radiation spikes, tech malfunctions, and even UAP sightings. The team's investigation has led them to uncover real, physical evidence of something unnatural buried inside the mesa. Can they uncover the truth once and for all? Don't miss the season premiere of The Secret of Skinwalker Ranch, Tuesday, June 3rd, with new episodes Tuesdays at 8, 7 Central, only on the History Channel.